Simulix offers a large flexibility to design your clinical trial simulation. In this video, we will see how to specify one or several simulation outputs. Each output is composed of the name of a variable from the longitudinal model and a time grid defining the times at which the values of the simulated variable will be given by Simulix. Let's first focus on the variables that can be used. I will use as example the model defined on this slide. Here I have written only the structural model and observation models in the block longitudinal. I will then load this model into Simulix. Here the structural model is a PK-PD model, where the PK includes a time-varying clearance defined in the variable CLAP, and the PD model is an indirect inhibition. You may notice that the structural model must include a section output with a list of output variables and optionally a list of table variables. In this case, the list of model outputs is CC, the predicted concentration, and R, the predicted response. This section is mandatory for coherence with the other applications of the Monolix suite, in particular Monolix, which automatically maps the output list to the observed data, and which outputs the predictions for the variables in table. But the variables defined here are not the only possible simulation outputs. Actually, any variable defined in the block longitudinal can be chosen as simulation output. This variable can be of continuous, discrete, or even type. We classify the variables from the models into two groups, the main output and intermediate outputs. The main outputs are the variables that are probably the most interesting to define as simulation outputs. They include the variables defined in the section outputs of the structural model, either with output, like here CC and R, or with table if it is present, like here, as well as the observations defined in the observation model with a residual error model, here Y1 and Y2. The intermediate outputs are all the other variables of the model that can be defined as simulation outputs. They include intermediate variables defined in the structural model and not listed in the output section, such as in this case, the transformed parameter CLAP, which is the apparent clearance based on time and other parameters, or the transformed parameterKin. If AUC was not listed as table, it would also be such an intermediate output. In addition, regressors, such as R0 here, can also be defined as simulation outputs. Furthermore, note that it is possible to define additional variables in the structural model directly from the interface with the additional lines option that will be presented in a later video. All variables defined this way can also be used as simulation outputs. Finally, parameters and covariates are not available as simulation output, but they will appear in the Result tab and output files automatically. Let me now simulate this model with different simulation outputs. I have loaded this model into Simulix with the same longitudinal block as I have shown on the slide, with in addition a block individual to define inter-individual variability for the parameters, and a block covariate to define some covariates. I have already defined the elements that I need for the simulation, some values for the population parameters, distributions of covariates, a dosing regimen in treatment, and a typical value for the regressor. Now I only need to define the simulation output. In output, a list of default elements has already been automatically generated corresponding to one output element for each main output of the model, the observations Y1 and Y2, the outputs of the structural model CC and R, and AUC, which is defined in table. I can check the time grid corresponding to the first output by clicking on View. As you see, the default grid is composed of one measurement per time unit from 0 to 100. The same default grid is used for all the default elements. Note that if I had imported a project from Monolix instead of only loading the model, the default time grid would be adapted to the measurement times from the original data. You can watch our video number 98 for more information. I can notice that some of these default outputs have been selected by default in the tab Exploration. They correspond to the default outputs for continuous non-random variables. Outputs for y1 and y2, which include random residual errors, cannot be selected here. In contrast, in the tab Simulation, any output can be selected, and by default the outputs selected are the ones for y1 and y2 to take into account the residual errors in the simulation. I will first focus on the default output for CC, and I will delete the others from Simulation and from the tab Definition as well. Of course, I can modify the default grid of regular CC by clicking on Edit. This opens a pop-up where I can change the time step and limits of the grid. I have defined a multiple dose schedule with the last dose given at time 168. Therefore, I am going to simulate the PK until time 200. I will also change the name of the output element for regular CC until 200. The output is automatically updated in simulation. Thus, when running the simulation for 10 individuals, I get a plot for CC with regular measurements from 0 to 200. By default, only curves are displayed, but I can also overlay the exact measurement times as dots. I will now create a new output element for an intermediate variable defined in my model. When clicking here, a pop-up opens with several options to define the time grid, as a regular time grid, as a manual list of times, or as an external table. I will choose for now regular. The output variable is specified here, and I can use a drop-down list to check the variable available in the main output and in the intermediate output. Here I will choose the variable CLApp, which is a time-varying clearance, with a Roth time grid of 5 points between 0 and 200. I call this output regular CLApp. In simulation, I can now add this new output and rerun the simulation. I get a new plot for CLApp where I can visualize the decrease in clearance with time. If, in addition to these 5 time points, I want more measurement times at specific times, for example, a few more time points at the start of the simulation to see better the decrease of the clearance, I can combine this output element with a new one for the same variable. This time, I create a manual output for CLApp, where I can enter manually here the additional time points that I want. Here 2, 4, 10, and 20. I name this output output manual CLApp. After adding it in the simulation, I have still one plot for CLApp, where the time grid combines the initial regular grid and the new manual times. Finally, I would like to simulate the PK with a design that mimics a real clinical trial that has already occurred to compare my simulations to the data from the trial. The effective measurement times have differed a little bit for each individual. I have them in this table, with a column ID and a column time. I can reuse the exact same times with an external output. I will simulate Y1, the PK with residual error, and I load here the table of individual times. I name this output output external Y1. Now, simulating this output, gives me a plot with residual error where the time grid is specific to each individual. Now you know everything about simulation outputs. See you next week for another feature of the Monolix suite.